Imagine you're an astronaut.
Okay.
You're just floating there in low Earth orbit. You're looking down at this immense, unending beige expanse of the Sahara Desert.
Right, just sand for miles and miles.
Exactly. You're watching the dunes roll by at, 17,000 miles an hour? Taking in hundreds of miles of just desolation.
Just a massive empty canvas.
Yeah, but then, out of nowhere, you see it. Staring right back up at you from the remote dry plateau in Mauritania is this massive 40-kilometer-wide, perfectly concentric bullseye.
Oh yeah, the Eye of the Sahara, it's striking.
It's insane. It's the series of rings within bands of orange, gray, purple rock. It looks for all the world like a giant cosmic target painted directly onto the crust of the Earth.
It really does. I mean, nature, as we usually experience it, rarely draws perfect geometric circles on a 40-kilometer scale.
Right. And for decades after it was first photographed from space, it sparked the absolute wildest speculations. Like, was it a catastrophic asteroid impact?
Or a deeply buried alien structure, yeah.
Or, the sunken fossilized ruins of Atlantis.
Which is a theory that just refuses to die.
It really does. And today, our deep dive is dedicated entirely to this geological marvel, the Richat Structure.
Famously known as the Eye of the Sahara, or Gelb or Richat.
Exactly. And for you listening, we are pulling from a massive, highly technical stack of sources today to really unpack this.
Yeah, we have satellite imagery analyses from the European Space Agency, NASA data.
Comprehensive geological surveys, too, plus peer-reviewed petrological studies mapping its deep magmatic roots.
And we can't forget the verified archaeological records from the surrounding desert. The volume of data on this single structure is staggering.
It really is.
We'll be synthesizing foundational papers from researchers like Matten and Jibrock, who mapped the bizarre collapse center of the structure.
Right, the breccia.
Exactly. As well as recent geophysical modeling from Abdina and colleagues that finally detailed the deep plumbing beneath it.
So our mission today is to sift through all of that data. We're going to separate the peer-reviewed science from those persistent viral myths.
Because the verifiable truth of this landscape is infinitely more fascinating than any of the internet legends.
So true. We're going to trace the actual origin story, which takes us from immense continental rifting deep underground to these catastrophic subterranean collapses all the way to hundreds of millions of years of just relentless erosion.
It's an incredible timeline.
So if you're listening right now, keep that image of the giant bullseye in your mind. Because to really grasp why the Richat Structure has been so profoundly misunderstood, we have to start by talking about scale.
Scale and perspective are everything here. I mean, they dictate everything about how we interpret this landscape.
Because it's huge, right?
It is. It's a slightly elliptical dome spanning roughly 40 to 50 kilometers in diameter.
Just to put that into perspective for everyone,
Yeah.
if you were to drop a sprawling major metropolitan area, say the entire city of Chicago or London, right into the center of it,
The outer suburbs would only just be brushing up against those outermost rings.
that is massive. But here's the crazy part. The paradox is that if you're actually there, standing on the ground, trekking across it on foot, you wouldn't see a bullseye at all.
Not even a little bit. It is practically invisible as a cohesive circular shape from the surface.
You would just perceive a series of rugged, steep-sided ridges made of hard rocks, and they'd be separated by these wide, shallow, sandy valleys.
Right. You'd just think you were in a particularly harsh, hilly part of the Mauritanian desert. You wouldn't know you were in a circle.
And geologists have a specific name for those types of ridges, right?
Yeah, we refer to those asymmetrical ridges as cuestas.
Cuestas. Okay.
So if you're standing on top of one, you're looking down a sharp, sheer cliff face on one side and a very gentle, sloping incline on the other.
Oh, I see.
And you can literally hike over cuesta after cuesta and never once realize they are curving around you in a massive ring.
It's only when you pull back significantly that the geometry snaps into focus.
Exactly. I mean, it was actually mapped back in the 1930s and 40s by French geographers doing ground and low aerial surveys.
And what do they call it?
They named it the Richat buttonhole.
A buttonhole.
Yeah, Boutonnière de Richat, because from their relatively low vantage point, it just looked like a slit in the ground revealing older rocks beneath the desert fabric.
It's so funny to think they just saw a buttonhole, completely missing the giant target.
Yeah.
But it really eluded global flamme until, June of 1965?
Yep, 1965. This is where the space race inadvertently changes geology.
The Gemini the Fifth mission.
Right. NASA astronauts James McDivitt and Edward White were orbiting the Earth in Gemini the Fourth, and part of their explicit mission parameters was to photograph the Earth's surface.
They were actively looking for large circular features.
They were. At the time, planetary geologists were desperate to find ancient impact scars on Earth.
To prepare for the moon landings.
Exactly. They needed to understand heavily cratered surfaces. So when McDivitt and White passed over the Western Sahara, they snapped a photograph.
Frame GEM 0416346670 for anyone keeping track.
That's the one. And it captured this staggering, near-perfect ringed structure rising out of the dunes. It served as a visual landmark for orbital crews ever since.
It kind of reminds me of one of those giant magic eye posters.
Or,
A massive Rorschach ink blot.
oh, that's a good way to look at it.
Right, because if your nose is touching the page, you just see a chaotic mess of squiggles and lines. The pattern is completely hidden by proximity.
You have to step all the way back across the room to see the boat or whatever it is.
Exactly. Or in this case, you have to pull back into the thermosphere to actually perceive the unified image of the bullseye.
And when you do pull back to that orbital vantage point, the geography of the surrounding region really emphasizes its isolation.
How so?
Well, it sits on the northwestern edge of the Taodini Basin, elevated on the Adrar Plateau. And because there is just a sheer lack of vegetation, you have these vivid contrasting colors.
The orange, the gold, the dark gray of the rock.
Right, and those exposed sedimentary and igneous rocks stand out violently against the pale, endless beige of the Ergudane sand dunes.
Which kind of just lap right up against the southern perimeter of the structure.
Revolves on a beach, yeah.
I have to say, looking at the historical context, if I'm an early planetary geologist in the 60s, and I see a giant 40-kilometer, perfectly concentric circle essentially stamped into the desert from space.
You're going to think meteor crater.
I mean, it makes total logical sense. Big hypervelocity rocks fall from the sky, they hit the crust, they leave big circular holes. Why wouldn't it be an impact?
It feels like the most obvious deduction you could make, and honestly, it was the prevailing hypothesis for a while.
It wasn't just a blind guess, though, right?
No, not at all. It was considered a highly educated hypothesis at the time, because an expedition in 1952, led by the French naturalist Théodore Monod, had already documented 3 real, confirmed meteorite impact craters relatively close by.
Oh, wow, right in the same desert.
Yeah, in Mauritania, the Awalou, Demichek Galaman, and Tenemer craters.
So the regional precedent for extraterrestrial impacts was already firmly established in the literature.
Completely. They knew the neighborhood had a history of getting hit by space debris.
So they look down, they see the biggest circular structure of them all, and they naturally assume it's the grandfather of all impact craters.
Yeah.
An astroblane.
Which means star wound.
Star wound. I love that term.
It's very poetic.
Right.
And by 1964, it actually appeared that the impact theory was sealed as absolute empirical fact.
Okay, wait, how? Did they find a meteorite?
Not a meteorite itself, but a French geologist named André Caillou and his team published a paper claiming they had found the definitive smoking gun.
Which was?
A specific mineral called coesite.
Coesite. Let's drill down into this, because understanding why this mineral matters is so crucial to the story. Why does finding coesite automatically make scientists assume a meteorite hit the rock?
Well, coesite is a high-pressure polymorph of silica.
Okay, in plain English.
Basically, it's quartz that has been subjected to such unimaginable, instantaneous physical pressure that its actual atomic lattice structure is forced to change. It becomes much denser.
Oh, I see.
And on the surface of the Earth, you generally only get coesite forming under intense shock pressures, specifically pressures exceeding 2 gigapascals.
2 gigapascals? Okay, most people, myself included, don't have a visceral sense of what a gigapascal even feels like.
Right, it's hard to fathom. To put it in perspective, think about the pressure at the very bottom of the Mariana Trench.
The deepest part of the ocean, crushing pressure.
Exactly. The pressure there is about 1/10 of 1 gigapascal.
Wait, really? Only 1/10?
Yep. So to make coesite, we are talking about a localized pressure 20 times greater than the bottom of the ocean.
That is terrifying.
And applied in a fraction of a millisecond. You just cannot get that from normal tectonic plate movement or even regular volcanic eruptions.
So the only way to get that kind of instantaneous catastrophic shock wave is if a hypervelocity object traveling tens of thousands of miles an hour slams into the crust.
Exactly. If you find coesite at a surface site, the laws of physics essentially dictate that you are standing in an impact crater.
Case closed then. Star wound confirmed by the chemistry.
Well, you would think. But science relies on reproducibility. And this is where rigorous, boots-on-the-ground fieldwork comes in and completely dismantles what seemed like a perfectly tidy theory.
Ah, the plot thickens. What happened?
In 1969, American geologists Robert Fudali, Robert Dietz, and William Cassidy traveled to the remote Richat to conduct comprehensive, localized field surveys.
They went to double-check the French team's homework.
Exactly. Fudali specifically targeted the deposits of shattered sandstone where Caillots's team claimed to have found the coesite.
And what did he find?
He took the samples back to the lab, subjected them to rigorous optical and X-ray diffraction examinations, and
The roll, please.
it revealed a classic, albeit very embarrassing, case of mineralogical misidentification.
Oh, no.
Yeah. The atomic spacing and reflections that the French team had attributed to coesite actually belonged to barite.
Barite, dude. Wait, isn't that the sulfate mineral they use to weight drilling mud in oil wells?
That's the exact stuff. It's a very common, entirely harmless sulfate mineral that just precipitates out of regular groundwater.
So it requires absolutely zero shock pressure to form.
None whatsoever. Fudali definitively proved that there was zero coesite in the Richat structure.
Wow. It's essentially a geological false
A
positive.
huge false positive.
It's like a forensic investigator, showing up at a house, finding a massive red puddle on the floor, and immediately declaring a grisly crime scene.
Right.
But then the lab analyzes the swab and confirms, nope, it's just spilled red acrylic paint.
That is a brilliant analogy. The visual cue heavily suggested one very violent narrative, but the chemical reality told a completely different, much more mundane story.
That has to be so deflating for the impact theorists.
Oh, it was a massive blow. And once that supposed smoking gun was debunked, Dietz, Fudali, and Cassidy broadened their survey.
Looking for other impact clues.
Yeah, and they realized that the Richat structure was missing basically all of the other diagnostic markers that define a hypervelocity impact crater.
Okay, so if a rock the size of a mountain hits the Earth and leaves a 40-kilometer scar, what physical evidence has to be left behind besides the coesite?
Well, for one, the mechanics of the ground movement. When a massive object strikes the Earth, the kinetic energy transferred is so immense that the solid bedrock temporarily behaves like a fluid.
Like a liquid.
Yeah, the ground compresses downward violently, and then immediately after the shockwave passes, the center of the crater rebounds upward.
Like a drop of water hitting a puddle and splashing back up in the middle.
Exactly. It snaps back to create a central uplift peak. You see this in craters on the moon all the time.
Right, those mountains in the middle of the craters.
But the Richat structure does not have a central rebound peak. In fact, its center is a flat downdrop depression.
Okay, so the mechanics of the ground movement are completely wrong.
Entirely wrong. And there's more. They looked for shocked quartz exhibiting planar deformation features.
Which are what, exactly?
They're microscopic, closely spaced, parallel fractures inside the quartz grains caused by the passing shockwave.
And did they find any?
Not a single one.
Wow.
They also looked for shatter cones. These are macroscopic, radiating cone-like fracture networks in the bedrock that literally point back toward the source of the shock.
Like little arrows pointing to where the meteor hit.
Exactly. Again, they found zero. And finally, no evidence of impact melt glass and no trace of extraterrestrial siderophile elements.
Like an iridium anomaly.
Right, which meteorites are typically very rich in.
Okay, so let's tally this up. We have no shocked quartz, no shatter cones, no melted rock, no central rebound peak, and absolutely no iridium.
Nothing.
The astroblum theory didn't just have a hole in it. It completely evaporated under scrutiny.
It was completely dead in the water.
Which leads to a massive pivot, right? Because if the immense force that created this 40-kilometer bullseye didn't come crashing down from the cosmos,
Geologists had to look in the exact opposite direction.
they had to look deep underground.
Precisely. If the hammer didn't strike from above, the engine had to push from below.
So what is the modern consensus? What actually built this thing?
The modern geological consensus, which was really built on decades of work and heavily crystallized by researchers like Guillaume Metton, Michel Gebrock, and James Lee in their 2005 paper.
We love a good landmark paper.
Oh, it's foundational. They concluded that the Richat is a deeply eroded structural dome formed by a highly complex internal magmatic history.
Magma, so it's volcanic.
Terrestrial magmatism, yes. And recent advancements, like a 2024 paper by El Hussein Abdina and his team, they used aeromagnetic and gravimetric data to map the deep plumbing.
Basically taking an MRI of the Earth's crust underneath it.
Exactly. And what they revealed is that this wasn't just a single event. It is a two-stage magmatic engine,
Two stages.
and those stages are separated by 100 million years of silence.
That is just wild to think about. A two-stage engine spanning deep geological time. Okay, let's dig into stage one because this takes us back 200 million years.
Deep into the past.
To set the scene for everyone listening, 200 million years ago, we are at the boundary of the Triassic and Jurassic periods. What is happening on a planetary scale at this exact moment?
Well, the Earth's landmass is utterly dominated by the supercontinent Pangaea.
All the continents mashed together.
Right, but at this specific moment, roughly 200 million years ago, Pangaea is beginning to fatally fracture. It's tearing itself apart.
And when a supercontinent rips apart, I imagine it's not a quiet process.
It is violent. This immense continental rifting triggered a colossal pulse of deep mantle volcanism. Geologists call it the Central Atlantic Magmatic Province, or CAMPIMP.
Sorry, I'm bound.
It remains one of the largest igneous events in the history of the Earth. It's the direct geological mechanism that actually forced the opening of the Atlantic Ocean.
Wow. So you have immense tectonic stress. The Earth's crust is literally ripping open along these vast fault lines, and mantle magma is surging upward everywhere.
Everywhere. And the deep plumbing beneath what is now Mauritania gets its first massive influx of this magma.
So what does that look like underground?
The geophysical models detailed two massive concentric bodies of gabbro deep within the Richat Structure.
Yeah, bro. What kind of rock is that?
Gabbro is a dense, dark, intrusive igneous rock. It's essentially the coarse-grained, slowly cooled equivalent of basalt.
Okay, so big blobs of slow-cooling magma.
Right. And for a long time, early models assumed these were vertical ring dikes,
They what?
meaning massive cylindrical walls of magma that shot straight up vertically through the crust, like a chimney.
Okay, but the new models say something different.
Yeah, Abdina's recent modeling of the magnetic and gravity anomalies suggests they are actually horizontal sills.
Wait, horizontal.
Horizontal.
But if you have highly pressurized magma surging up from the deep mantle, why wouldn't it just follow the path of a vertical fault and blow straight out onto the surface like a traditional volcano? Why does it suddenly turn sideways?
It's a great question. It all comes down to lithostatic pressure in stratigraphy.
Break that down for me.
Sure. So the Richat area sits within the Taudani Basin. This basin is composed of massive, flat-lying layers of sedimentary rock. Limestones, sandstones, shales.
Stacked on top of one another like a giant layer cake.
It's exactly like a layer cake. As the magma rises, it has to overcome the immense weight of all that rock above it.
For lithostatic pressure.
Right. Eventually, it reaches a specific depth where the pressure required to break vertically through the next dense layer of rock is simply greater than the pressure required to force its way horizontally between two existing layers.
Ah. So the magma finds a plane of weakness, like a bedding plane between the sedimentary strata.
And it injects itself sideways, totally parallel to the layer.
I see. So it's not punching through the ceiling, it's wedging itself between the floorboards.
That is a perfect way to visualize it. And the scale of these sills is just massive. The models show an inner sill that is roughly 30 meters thick, sitting at a 3-kilometer radius from the center.
30-meter thick of solid magma pushing in.
And an outer sill that is 70 meters thick at an 8-kilometer radius.
So it's essentially taking a massive flat layer of underground rock and injecting a 70-meter thick disk of molten rock right underneath it.
Right.
That immense volume of magma has to displace something. It can't just occupy the same space.
No, it forces all the sedimentary layers above it to bulge upward. It creates a colossal geological blister or dome on the surface.
A giant blister. Okay, so the injection of the CAMP magmas domed the overlying rocks. But then what? Does it erupt?
No, the initial magmatic engine just shut down. The gabbro slowly cooled and crystallized over thousands of years, locked underground.
But wait, our sources indicate that there are other igneous rocks right in the center of the structure, and they date to around 100 million years ago, not 200.
Right, there's a huge time gap.
So did that initial magma chamber just sit there dormant for 100 million years and then suddenly decide to reactivate?
Not exactly the same magma, but the same plumbing. This highlights a really profound geological concept. The Earth's crust remembers where it was broken.
The crust has a memory. I like that.
It does. The deep faults, the fractures, the vertical pathways created in the lithosphere during that initial Pangaean rifting event, they didn't just heal and go away. They remained as a pre-existing structural weakness deep underground.
Okay, so fast forward 100 million years. We're now roughly 100 million years ago, deep in the mid-Cretaceous period.
Dinosaurs are everywhere.
Right. Spinosaurus and Carcharodontosaurus are roaming North Africa. The Atlantic Ocean is steadily widening. What triggers the engine beneath the Richat to fire back up?
A new localized thermal anomaly begins to push upward from the mantle, a hot spot of alkaline magma.
And because ascending magma will invariably take the path of least resistance.
It exploits those exact same deep-seated fault systems left behind by the CMP event.
It uses the old highway.
Exactly. But this secondary intrusion was highly energetic and chemically distinct from the first one. It brought up volatile-rich magmas, specifically carbonatites and kimberlites.
Hold on. Isn't that the host rock that transports diamonds from the deep mantle to the surface?
It is, though we should definitely clarify for anyone packing a shovel right now that no economically viable diamonds have ever been found at the Richat.
Good to know. Leave the shovels at home, folks.
Yeah, please do. But finding kimberlite plugs, which radiometric dating places firmly at roughly 99 million years old, alongside carbonatite dikes dated between 94 and 104 million years old.
That tells us something specific about the eruption.
It tells us this was a highly pressurized, volatile, very gas-rich event. This massive secondary upwelling pushed directly beneath the already existing dome.
So the blister gets pushed up even further.
Right, thrusting the late Proterozoic and Ordovician sedimentary rocks even higher, tilting them outward at 10 to 20 degree angles.
It's stretching the sedimentary skin of the crust incredibly tight.
Very tight.
But reading through the sources, the most bizarre and chaotic part of this entire structure isn't those outer tilted rings. It's the very center of the eye.
The megabreccia.
Yes, the geological papers call it a siliceous megabreccia. It's 3 kilometers wide and 40 meters thick. We really need to break this down. First, just basic definitions. What exactly is a breccia?
In geological terms, a breccia is a specific type of rock composed of large, highly angular, broken fragments of older rocks.
Like gravel.
Sort of, but gravel is smooth. These fragments are angular, and they've been subsequently cemented together by a fine-grained matrix.
So the angularity of the fragments is the key.
Exactly. It tells you the rock was shattered in place and not rolled down a riverbed, which would have rounded the edges off. And a megabreccia simply indicates that this shattering process occurred on a massive structural scale.
So right at the center of the Richat, there is a 3 kilometer wide chaotic jumble of shattered chert, quartzitic sandstone, and ancient stromatolic limestone, all glued together by microcrystalline quartz.
That's it.
I mean, you could easily see why the early geologists clung to the meteorite impact theory. A giant circular crater filled with millions of tons of shattered angular rock just screams impact site.
It is a very, very compelling visual mimic. But Matten and Jebruck figured out the true mechanism, and it is a process known as hydrothermal karstification.
Hydrothermal karstification. The mechanics of this are incredible. Walk us through how hot water and magma create a 3 kilometer field of shattered rock.
Okay, so when that mid-Cretaceous alkaline magma complex intruded into the upper crust, it didn't just bring molten rock. Magmatic bodies release immense volumes of highly pressurized, superheated carbon dioxide-rich fluids.
Basically boiling acid water.
Exactly. These hydrothermal fluids migrated rapidly upward through the radial and concentric fault lines. Now, the bedrock sitting directly in the center of the Richat Dome at that specific depth was a thick, ancient marine shelf made of limestone and dolomite.
And limestone is highly susceptible to chemical weathering, right? Especially by acids.
Extremely susceptible. I mean, in modern surface environments, weak carbonic acid in regular rainwater slowly dissolves limestone over thousands of years to create cave systems.
Like Mammoth Cave.
Right. But beneath the Richat, you had superheated, highly acidic magmatic fluids interacting with the limestone shelf from below. The heat and the chemistry caused incredibly rapid dissolution.
So this is karstification occurring on a catastrophic subterranean scale.
The fluids literally ate away the bedrock. They created massive, echoing caverns and voids deep, deep underground.
Unbelievable.
Furthermore, the fluids chemically altered the surrounding rocks through a process called metasomatic skarn alteration.
Okay, hold on. What is metasomatic skarn alteration?
Right. Basically, metasomatism is when hydrothermal fluids exchange ions with the host rock. They fundamentally change its chemical composition without actually melting it.
So it's baking it and changing the chemistry.
Right. The hot, mineral-rich fluids react with the carbonate rocks to form a new, distinct suite of minerals called skarn. This process requires significant thermal energy and, crucially, significant geological time for the chemical exchanges to occur.
So the magma is baking the rock, altering its chemistry, and the acidic fluids are dissolving massive voids in the limestone foundation.
You're starting to see the problem.
Yeah, you have this massive dome of heavy sedimentary rock pushed up into the air, but directly underneath the center of it, the foundational pillars are just being eaten away.
It creates an inherently unstable physical system.
It has to collapse.
And it did. The span of the caverns grew too great, and the millions of tons of overlying rock were simply too heavy. Eventually, the structural integrity of the cavern roofs suffered a massive, catastrophic gravitational failure.
The roof just gave out.
The entire roof collapsed downward into the subterranean void. The overlying layers of brittle chert and sandstone fractured and shattered into millions of angular fragments as they fell into the abyss.
It's essentially a subterranean bridge collapse.
That's exactly what it is.
The acidic water eroded the foundational pillars until the immense weight of the span above snapped the bridge in half, sending all the debris crashing down into the cavern below.
A 3-kilometer-wide pile of debris.
But wait, if it just collapsed into a pile of loose rubble, why is it currently a solid, cohesive disk of rock that people can walk on?
Because of the final step in the formation of the megabruchia, silicification.
Silicification.
Immediately following the collapse, a new pulse of hydrothermal fluids flooded upward through the highly porous rubble. But these fluids were heavily saturated with dissolved silica and barium.
Oh, I see where this is going.
As these fluids cooled and circulated through the empty gaps between the shattered rock fragments, the silica precipitated out of the solution.
It acted like an incredibly durable geological superglue.
Exactly. It cemented the entire chaotic mess of rubble back together into a solid, impenetrable mass of rock.
That is fascinating. And the most stunning part of this to me is that geologists know exactly when this subterranean cave-in occurred.
According to a very narrow window, yes.
How can we possibly date a localized cave-in that happened deep underground millions of years ago?
We use radiometric dating, specifically a technique called the argon-argon dating method, applied to potassium feldspar crystals.
Okay, I want to understand this. How does that geological stopwatch actually work?
So potassium-40 is a naturally occurring radioactive isotope, and it decays into argon-40 gas at a very specific, known, and constant rate.
Like sand falling through an hourglass.
Precisely. Now, when the hydrothermal fluids were filling the gaps in the collapsed breccia, tiny, fine-grained crystals of potassium feldspar began to grow within the matrix.
Okay.
While the rock is hot and fluid, any argon gas that is produced by the decaying potassium just escapes. It bubbles away.
The hourglass hasn't been flipped yet.
Right. Exactly. But the moment those newly formed feldspar crystals cool below a specific threshold, which we call the closure temperature, the crystal lattice locks shut.
It traps the gas.
The argon gas can no longer escape. It begins to accumulate inside the crystal over millions of years.
So then you just count the gas.
Basically. By taking these crystals to a lab, using a mass spectrometer to measure the exact ratio of the remaining potassium to the trapped argon gas, we can calculate precisely how long it has been since that crystal cooled and locked shut.
It's just a breathtaking application of chemistry and physics.
It really is. And the argon-argon dating of the feldspar within the breccia matrix places this exact hydrothermal collapse and silicification event at 98.2 plus or minus 2.6 million years ago.
98.2 million years ago. Okay, so let's lock in the timeline for everyone.
Sure.
100 million years ago, the dome has been pushed up to its maximum height by the secondary magma pulse. The center has gravitationally collapsed in on itself, filling a giant void, and it's been superglued together by silica.
The structural canvas is finally set.
Right, but if you were hovering in a time machine above Mauritania 100 million years ago, looking down at this, it still wouldn't look like the flat bullseye we see today, would it?
Not at all. It would likely look like a broad, highly elevated, rugged mountain or a huge hill, perhaps with a jagged, collapsed caldera-like depression right in the center.
But it wouldn't have the striking, concentric, two-dimensional geometry that makes it so famous.
No. To achieve that pristine, flat bullseye, we require the final sculptor in this geological narrative.
Which is?
Time. Specifically, 100 million years of relentless, continuous erosion.
Right, because this massive structure is sitting squarely in what will eventually dry out to become the Sahara Desert.
Exactly. For tens of millions of years, the forces of physical weathering, primarily aeolian or wind-driven erosion, combined with episodic water erosion during wetter climate phases, They acted like a giant planetary orbital samber.
Just constantly grinding away at the rock.
Wind carrying fine grains of sand acts as a constant abrasive, slowly blasting away the rock. Over deep time, this erosion essentially sliced the top off the entire dome, leveling it out.
Okay. But if you just sand down a dome, you get a flat circle. How do we get the distinct rings, the ridges and valleys?
That is the key. The concentric ring pattern is the result of a concept called differential erosion.
Differential erosion, meaning the wind doesn't sand everything down at the exact same rate.
Precisely. Different rock types resist the abrasive force differently. If the Richat Dome had been composed entirely of one uniform type of homogeneous rock, the wind would have just worn it down into a smaller and smaller, smooth, featureless mound.
Like a sandcastle washing away.
Right. But the sedimentary layers of the Taudani Basin are heavily stratified. They're like a layered cake.
Okay.
You have strata of incredibly hard, highly resistant rocks like metamorphosed quartzite, alternating with thick layers of much softer rocks like limestone and friable sandstone. And of course, you have those deeply buried rings of tough igneous gabbro from the original sills. Ah, I see. So as the wind and sand blast horizontally across the top of this sliced-off dome over millions of years, the soft limestone and the crumbly sandstone just yield easily.
They are literally scooped out and blown away across the desert.
And those eroded sections become the deep, circular, sandy valleys.
Yes. But the tough quartzite layers and the dense gabbro sills refuse to yield. They stand firm. And as the softer rock around them disappears, they are left towering above the valleys as those high-relief, circular cuesta ridges we talked about earlier.
So the physical properties of the rock itself dictate the topography.
Exactly. And because the original layers were domed upward before they were eroded flat, slicing the top off reveals the chronological sequence of the rocks in concentric circles.
Okay, if you'll allow an analogy, I think I have a good way to picture this.
Go for it.
It's exactly like slicing the top off an onion.
Right. If you take a whole onion and cut it perfectly in half horizontally, you see all the concentric rings laid out on a flat plane. The very center of the cut onion is the oldest part, the inner core that grew first. And as you move outward toward the skin, you cross the newer outer layers.
It functions exactly like that. It's a perfect analogy. At the Richat Structure, the oldest rocks, the Proterozoic limestones and dolomites that were deposited over 500 million years ago, are exposed right in the very center, near the collapsed breccia.
And as you walk radially outward from the center,
Crossing the valleys and the ridges, you are stepping across progressively younger and younger rocks. You finally end with the Ordovician sandstones on the outermost perimeter.
it is literally a textbook. Massive scale cross-section of Earth's stratigraphy laid entirely flat on the desert floor for anyone to read.
It's a geologist's dream.
It is an utterly awe-inspiring story of terrestrial power. I mean, just think about it. You have deep mantle magma tearing a supercontinent apart 200 million years ago. A highly acidic hotspot hollowing out the crust 100 million years ago. A catastrophic structural collapse. And then millions of years of wind and sand painstakingly polishing it into a masterpiece of differential erosion.
It's a lot to wrap your head around.
It is. But because the visual perfection of those eroded rings is so striking, it has historically driven people to look for explanations far beyond conventional slow-moving geology.
Right. When a natural structure looks highly ordered, the human brain instinctively searches for an intelligent designer, or a rapid catastrophe that defies the concept of deep time.
Which brings us to the fringe theories.
It's a very common phenomenon in geology, honestly. When the immense scale of geological time is difficult to conceptualize, alternative narratives rush in to fill the void.
And the most prominent of these narratives, which frequently goes viral on the internet, is the theory that the Richat Structure is the physical location of the lost city of Atlantis.
Yes, the Atlantis theory.
Our mission here is to impartially look at what the sources say about these claims. Let's start with the origin. Where does the specific association between a geological dome in Mauritania and a mythical sunken city actually come from?
Well, the foundation of the Atlantis narrative stems entirely from the writings of the ancient Greek philosopher Plato, specifically within his dialogues Timaeus and Critias, which were written around 360 BCE.
Okay, so Plato is the source. What did he say?
In these texts, Plato describes Atlantis in great detail as a magnificent, advanced city constructed around concentric rings of alternating land and water.
Alternating wings of land and water. I mean, you look at the satellite imagery of the Richat structure, you see alternating rings of high rock ridges and low sandy valleys. I can easily see why people scrolling through Google Earth make that immediate geometric leap.
The superficial geometric similarity is definitely the primary driver of the theory.
Are there other connections they draw?
Proponents also note that Plato stated Atlantis was located beyond the Pillars of Hercules, which is the classical term for the Strait of Gibraltar.
And Mauritania is geographically southwest of Gibraltar, so it fits that broad directional parameter.
It does. They also accurately point out that the Sahara Desert was once lush, green, and heavily watered, suggesting the region possessed the ecological capacity to support a massive, hidden civilization.
Okay, so that is the premise of the claim. But when we apply the source material, the empirical geology, the radiometric dating, and the verified archaeology, how does the Atlantis hypothesis actually hold up to scrutiny?
Under rigorous scientific examination, the hypothesis completely dismantles itself across multiple independent disciplines.
Let's walk through them. Where does it break down first?
Let's start with basic geography and tectonic reality. Plato's Atlantis was explicitly described as an island continent that sank entirely beneath the ocean in a single catastrophic day and night of earthquakes and floods.
An island that sank.
Right. The Richat Structure is a 40-kilometer geological dome situated roughly 500 kilometers inland from the Atlantic coast. It's sitting at a high elevation on the Adrar Plateau.
So it's not an island, and it's not underwater.
It is embedded in the continental crust, and there is absolutely zero geological or sedimentary evidence that the structure ever sank into the ocean or was inundated by a localized marine catastrophe during human history.
So the physical location and state of the land contradict the text. And then there's the fundamental issue of the timeline.
The timeline is perhaps the most intractable problem for the Atlantis theory.
Break that down.
Well, the complex geological processes that formed the Richat, the dual magmatic doming, the hydrothermal skarn alteration, the cavern collapse, and the subsequent silicification, they occurred tens of millions of years ago.
Right. The argon dating put the collapse at 98 million years ago.
Exactly. Furthermore, the erosion required to shave the dome down to those perfect rings took tens of millions of years more.
So it's ancient.
This entire structure was formed, collapsed, and eroded into its current geometric shape millions of years before the very first hominins even evolved.
Let alone before anatomically modern humans developed advanced civilization.
Right. Metallurgy, complex agriculture, urban planning, none of that existed. There was simply no human civilization in existence to build a city on this structure when it was forming.
But what about the actual physical archaeology? Let's say the dates are wrong. If there was a metropolis 40 kilometers wide, a hub of a global maritime empire, surely an archaeological survey would uncover something. A foundation, a canal wall, even just a dense concentration of pottery.
The absence of evidence in this case is definitive. Archaeologists have surveyed the Adrar Plateau extensively. Within the Richat structure, there is absolutely zero evidence of built, engineered structures.
Nothing.
No excavated canals, no stone foundations, no domestic refuse middens, no pottery sherds, no evidence of metallurgy or smelting, and no advanced ruins of any kind that would correlate with a Bronze Age or older advanced civilization.
As skeptics Stephen Novella and archaeologist Sean Rafferty point out in our source materials, it is physically impossible to have a massive, highly advanced, heavily populated city occupy a location and leave zero trace of urban infrastructure behind.
It just doesn't happen. The overwhelming consensus among historians and classicists is that Plato invented Atlantis not as a historical record, but as a rhetorical device.
A philosophical fable.
Exactly. It was designed to illustrate the moral dangers of hubris and imperial overreach.
Okay, so the geological and archaeological data definitively rule out a lost city. But our sources also detail another alternative theory, one that doesn't claim a city, but rather challenges the entire concept of deep-time geology altogether.
Ah, yes. It's referred to as the catastrophic aqueous vortex model, or CAVM.
CAVM. Let's lay out what the CAVM claims, strictly adhering to the arguments presented in the literature. What is the fundamental mechanism they propose for the rings?
Proponents of the catastrophic aqueous vortex model argue that the Richat structure's distinct concentric geometry, the brecciated center, and the deeply incised valleys are not the result of 100 million years of slow tectonic uplift and differential erosion.
What do they think did it then?
They posit that the entire structure was carved incredibly rapidly by a single high-energy hydrodynamic event.
Water.
Specifically, a massive stationary horizontal water vortex.
Like a massive whirlpool carving the rock like a drill. And when do they claim this highly energetic event occurred?
The model ties this event to a global flood scenario, proposing it occurred approximately 4,400 years ago.
4,400 years. That is very recent.
Right. It's synchronized with a theoretical framework called catastrophic plate tectonics. The hypothesis suggests that a massive geological weak point allowed for the rapid upwelling of magma, while simultaneously a stable, highly energetic aqueous vortex rapidly ground out the circular rings in the sedimentary rock above it.
Do they offer evidence for this marine event?
They point to the verified presence of Paleozoic marine fossils, such as trilobites and brachiopods, within the sedimentary layers of the outer rings.
Okay, so they say those marine fossils are evidence of a rapid, catastrophic marine inundation that swept sea life inland.
Yes, that is their interpretation.
So the CAVM premise is rapid magma upwelling paired with a catastrophic flood vortex carving the rings a few thousand years ago. How does the mainstream geological community, utilizing the peer-reviewed data we've been discussing, address these specific claims?
The scientific consensus rejects the CAVM based on multiple intersecting lines of hard physical evidence. First and foremost, the radiometric clocks.
The argon dating we talked about.
Yes, the argon dating of the K-feldspar and the central breccia, the uranium-lead dating of zircons and the magmatic intrusions, and the fission track dating of the carbonatites.
Those are all different dating methods.
Yes, and they are rigorous, highly repeatable tests based on the immutable decay rates of radioactive isotopes. They consistently and independently place the magmatic and hydrothermal events between 200 million and 98 million years ago.
So a 4,400-year time frame is fundamentally incompatible with the physics of radioactive decay measured in these rocks.
The physics just don't allow it.
What about the marine fossils the CAVM proponents point to? Those are real fossils, right? They didn't make those up.
The fossils are absolutely real, but their presence is easily explained by standard stratigraphy.
How so?
The sedimentary rocks themselves, the limestones and sandstones of the Taudini Basin that make up the outer rings, they were originally deposited at the bottom of shallow, ancient seas hundreds of millions of years ago during the Proterozoic and Paleozoic eras.
So the marine fossils are embedded deep within the matrix of the rock layers themselves because the creatures died in those ancient seas as the rock was forming.
Exactly. They were not deposited loosely on top of the structure by a recent flood. They are an integral part of the ancient rock that was later pushed up into the dome.
And beyond the dating and the fossils, does the physical chemistry of the rock support a rapid event?
It directly contradicts it. The complex structural evidence we discussed, specifically the metasomatic skarn alterations and the slow dissolution of the carbonate shelf by hydrothermal fluids, these are highly complex physical and chemical processes.
They require a lot of heat and time.
Significant, sustained thermal interaction over long geological timescales. You cannot rapidly alter the chemical composition of millions of tons of limestone and form skarn minerals in a matter of days or weeks during a flood event. The thermodynamics simply do not allow for it.
So the peer-reviewed science firmly rejects both the Atlantis myth and the recent catastrophic flood model, grounding the structure firmly in deep-time terrestrial magmatism and slow methodical erosion.
The data speaks for itself.
However, just because there are no mythical Atlantean temples hidden in the sand, that absolutely does not mean the Richat Structure is devoid of an incredible human history.
Oh, not at all.
Our sources indicate there was a very real, scientifically verified archaeological record localized right here.
There is, and honestly, it is arguably much more profound regarding the human origin story than any myth. While archaeologists have found no ruined cities, the outermost rings of the Richat Structure and the surrounding plateau have yielded vast amounts of authentic Paleolithic stone tools.
Paleolithic tools.
Specifically, tools categorized within the Acheulean industry.
The Acheulean industry. Let's detail this for the listener. What specific kinds of tools are we talking about finding scattered around the eye of the Sahara?
We are talking about highly specific manufactured implements, bifacial quartzite hand axes, heavy cleavers, and precise scrapers.
Okay, what does bifacial mean in this context?
Bifacial means the toolmaker intentionally worked both sides of the stone to create a symmetrical, sharp edge.
So these are not just broken rocks that happen to look sharp.
No, they require planning, spatial awareness, and a deep understanding of how quartzite fractures. And crucially, these were not made by anatomically modern humans, Homo sapiens.
Who made them then?
They were manufactured by our much older early hominin ancestors, primarily Homo erectus and later Homo heidelbergensis.
Wow. And the timeline for these tools is staggering, right? How old are these artifacts?
Well, the Acheulean tradition is the longest-running tool industry in human history, spanning a massive time frame. But tools of this specific type found in the region date back as far as 1 to 2 million years.
Up to 2 million years ago. That recontextualizes the entire landscape.
It fundamentally changes how you view the desert. What this archaeological evidence tells us is that early hominins were living, hunting, and operating lithic manufacturing sites right on the edges of the Richat Structure.
And it is vital to understand that they were not struggling to survive in a barren, hyper-arid, sandy desert like we see today.
Right, because the climate of the Sahara is not static.
It changes over time.
Far from static. Driven by variations in the Earth's orbit and axial tilt known as Milankovitch cycles, the Sahara experiences dramatic paleoclimatic shifts.
From dry to wet.
During various periods in the Pleistocene and Holocene epochs, the region experienced what we call green Sahara phases.
Plain Sahara.
The climate shifted dramatically, pulling the African monsoon rains far to the north. The current desert bloomed into a lush, teeming savanna ecosystem. It was completely crisscrossed by major river networks and massive permanent freshwater lakes.
Thinking about this reality, the verified history, is what truly amazes me. I mean, I understand why people scrolling the internet want the Richat to be Atlantis, a lost, highly advanced city with flying machines and crystal power grids. It makes the world feel like a fantasy novel.
It provides a sense of hidden magical history. It's very alluring.
But when you look at the empirical data, the reality is so much more powerful. Just visualize this for a second. You have ancient human ancestors, Homo erectus, possessing the cognitive leap to understand how to shape stone into symmetrical tools. They are sitting on the highly resistant quartzite ridges of a 100-million-year-old collapsed magma dome. They are chipping away at these hand axes, listening to the sharp crack of stone on stone. And they're looking out not over an endless dead sea of sand, but over a vast, green, vibrant savanna teeming with megafauna.
An absolute oasis.
They lived, hunted, and survived right on the edge of the eye of the Sahara during a time when it was a literal oasis of life. The deep time of the geology beneath them, combined with the deep roots of our own evolutionary history happening right on top of it. I mean, it makes a fictional sunken city seem almost trivial by comparison.
I think that is the most accurate and respectful way to view the structure. The true narrative of the Richat structure is a profound testament to the immense, dynamic, slow-moving power of the Earth's interior, and it serves as a silent witness to the incredibly deep roots of the human story.
We do not need to invent pseudo-historical myths to imbue this location with wonder.
Absolutely not. The intricate chemistry, the raw tectonic physics, and the verified archaeology, they provide all the awe we could ever possibly ask for.
It is a remarkable synthesis of disciplines. Let's take a breath and recap the incredible journey of this deep dive.
We've covered a lot of ground today.
We started with a visual mystery that was effectively invisible from the ground, only revealing its 40-kilometer concentric geometry when humanity finally achieved orbital flight.
We saw how the initial, highly logical assumption that a giant meteorite crater had scarred the Earth was rigorously tested by field geologists.
We learned how X-ray diffraction proved that what looked like high-pressure coesite was actually low-pressure barite, and how the absence of planar deformation features in shatter cones forced science to look deeper.
We then explored the true dual-pulse terrestrial engine. 200 million years ago, during the violent tearing apart of the supercontinent Pangaea, massive horizontal sills of dense gabbro magma were injected between sedimentary layers, forcing the crust upward to create the initial massive dome.
Then, 100 million years later, geological memory allowed a new, hot, acidic, carbon-rich magma intrusion to push up through those exact same faults.
This secondary pulse ate away the ancient limestone foundation from below through hydrothermal karstification,
which caused a catastrophic subterranean bridge collapse, creating a 3-kilometer central megabreccia, which was then permanently superglued together by silica precipitation.
Finally, we witnessed the immense power of deep time. 100 million years of relentless wind and episodic water slowly slicing the top off the dome.
Through the mechanics of differential erosion, the hard quartzite and gabbro were left standing as high circular ridges, while the soft limestone and sandstone were scoured out into deep valleys. It laid bare the stratigraphic history of the region like an onion sliced perfectly in half.
And we applied that empirical timeline to separate the hard science from the alluring stories. We looked objectively at the structural scale and radiometric dating that definitively rules out the Atlantis claims, and we examined the complex thermodynamics of skarn alteration that dismantles the catastrophic flood models.
Instead, we found that the true, verified treasure of the Richat isn't a lost Bronze Age city, but the 2 million-year-old Acheulean hand axes left behind by our earliest hominin ancestors living in a vibrant green Sahara.
It has been an absolute masterclass in geology, chemistry, and deep time.
It really has. But before we finish up today, I want to leave you with a final thought. Something to mull over long after you take off your geologist's boots.
Oh, I'm interested to hear it.
Think back to that opening image we discussed at the very beginning. The Gemini-face astronauts staring out the small window of their spacecraft in 1965.
Floating over the dunes?
The eye of the Sahara had been sitting there, hiding its true, complex nature in plain sight for millions of years. It was so massive, so seamlessly integrated into the chaotic topography of the desert floor that humanity literally had to leave the planet.
We had to invent space travel.
To finally find the right vantage point to perceive its perfect geometry. It just makes you wonder, what other incredible deep-time terrestrial structures are sitting right under our feet today? What other massive planetary scale patterns are we completely blind to right now, simply because we are too close to the canvas, just waiting for us to figure out how to step back far enough to finally see them?